Good evening. I'm making this video just because I want to. Actually, I have no obligation to make this, but I was having a conversation with a student today, and we were working on this number 5 from homework 3.1, and together, I mean, we saw something really interesting, something I think really valuable earlier. And if you watch the video from substitution elimination, at the very beginning, when I'm talking about elimination, I refer to there are going to be some instances where an adept Algebra 2 student can notice more than just substituting a single variable, but rather substituting expressions. And I was working today with this student, and we found this. He actually did some math thing that I'm going to replicate now, and together we discovered something I think that's really cool with substitution that I just wanted to share with you. Now, I am going to bring this up in class and talk about it, but gosh darn it, I just thought it deserved its own video. So this is Substitution Revisited, looking at it from a fresh perspective. Notice I say revisited from a fresh perspective. So here's what I'm going to do. I was talking with the student, and he suggested we need to find B or C, right? Notice, again, to sort of reiterate the strategy here, you've got A, B, C in the top, but you've got a 2x2 system beneath B and C, B and C, right? So I'm going to use substitution within the 2x2 to find either B or find C first, and then I will take that, figure out the other one, and then once I'm done with this 2x2, I'll plug B and C up in the first equation to figure out A. So let me show you what our student did. This is great. He said, let me take a look at B over 3 plus C over 2 equals 1. Now, what he noticed was that if you don't like fractions, you can get rid of fractions by multiplying by the denominator, right? And I have two fractions here, B over 3 and C over 2. And this is actually really great forward thinking because next semester we're going to do some stuff with rational functions. Remember, rationals 1 over x, right? And that's going to require us to locate a least common denominator. So like, if you had 1 over 3 plus 1 over 2, what's the least common denominator, right? It's 6, right? So you need to do 3 times 2. And so what he did was to get rid of both fractions in one fell swoop, right? If I multiply b over 3 times 3, that gets your b. But if you multiply c over 2 times 2, that gets you c. But I can't just multiply by 3, and I can't just multiply by 2 to get rid of both fractions. So if I multiply by 3 and 2, 2 and 3, right, I'll get 2b and I'll get 3c. But of course, 3 times 2 and 2 times 3 is 6. So that's what he did. He said, let me take this and multiply it by 6. 6 times b over 3 plus c over 2 equals 1. From here, let's multiply that out. I got 6b over 3 plus 6c over 2 equals 1. Oh, sorry, equals 6. I meant to put the parenthesis out there. I'm so sorry. Now, 6b divided by 3 is 2b, and 6c divided by 2 is 3c, and this equals 6. And he said, let me solve for b. So let's subtract 3c from both sides. And I've got 2b equals 6 minus 3c. Now, if you were going the traditional substitution route that, as I've kind of shown you, taught you, right, you would divide by 2 on both sides to get b alone, to isolate b. But here is what we noticed, and this is awesome. Don't divide by 2. Examine 2b, or not 2b, just kidding. 2b equals 6 minus 3c. But I have 2b up there. 2b plus 5c equals 14. So hold on a second. Wait a darn minute. I'm going to drag this up here, like so, and say, here's 2b plus 5c equals 14. But we just found that 2b equals 6 minus 3c. So I can replace, right, this 2b with this 2b. And this is what I meant by being adept, right? Being strong in algebra and strong in substitution. Not just isolating b, but noticing that if you multiply by 6, you get 2b, and 2b can be substituted. So this is what this becomes. You have 2b is 6 minus 3c, and then plus 5c equals 14, because I'm replacing 2b with that expression. So, of course, this is 6 minus 3c plus 5c equals 14. So, if you subtract 6 from both sides and combine like terms, you should get 2c. 2c equals 8. So divide both sides by 2, you get c equals 4. And that's one of our answers, right? I don't want to box. I like to box my final answer. I'll circle my mini answers. That's just a me thing. That's a Mr. Spake thing, not an official math practice. So I found C. Now I can find B, right? Now I found C. Now I can find B. Well, I say, 2b equals 6 minus 3c. So 2b equals 6 minus 3 times 4. And then 2b equals, 3 times 4 is 12. 6 minus 12 is negative 6. So divide both sides by 2, and b equals negative 3. Negative. Nice. And now you can take your b and c and substitute it into the top, right? So I'll go ahead and do that just so for the sake of the video it's all nice and carried out, because why would I stop the video there and not solve? 2a plus 3b plus c. Okay, 2a plus 3b plus c equals, was it negative 3? Okay. So I'll replace my b's and c's. 2a plus 3 times negative 3 plus 4 equals negative 3. So 2a, 3 times negative 3 is negative 9, plus 4 is negative 5. So I'll add 5 to both sides. 2a equals 2, so a equals 1. And so my final answer is, I don't want to do an ordered triplet. I'll just do a equals 1, b equals negative 3, and c equals 4. And I'll box that and call it a day. I don't really like that box. I'm going to try boxing it one last time. Okay, well, whatever. That is my final answer. And so there you go. So I just think that is really, really awesome that we were able to find that together and see that you can substitute not just b, but the expression 2 times b. I think this was totally unintentional when I made this problem up, but I love that it worked out this way. I think this is great. So hope you enjoyed this little substitution problem here. That's all I had for this video, just to show you something new, show you something creative. That I tell you, there's so many ways to do these, and I think this is really cool. So there you go.